we're going to talk about the domain and range of an inverse function and how inverse functions can kind of help us with problem solving. So let's say we read a problem, we built this equation. And the question is that your wage depends on your hours. So your f here, or f at x, they've written it as w at h being the variable in the equation, which is the amount of hours, so however number of hours you work, right? And this is the wages you earn. Your wages depend on that. And just for argument's sake, let's say in this case the person makes 15 bucks an hour and a weekly salary of 100 bucks. They have such a nice business that apparently you're so good at working, if you don't put in any hours, they'll stay to pay you 100 bucks a week, okay? Another way we could write something like this, and you might be more commonly writing like this is technically in function notation right now. Function notation. A lot of times you would have seen it maybe written like this. Wages is equal to 15 by hour plus 100, okay? And an inverse function, essentially what you're doing is you're setting the equation, we're flipping our equation to set it equal to something else here. So like we were saying, we were going to flip two things. So an inverse function, and usually when we write it, we'd write f to the power of -1 of x, okay? And we could write that here, wage to the power of -1 of h. But really what we're doing is we're reversing what we're finding, what we're solving for. And because this is a problem, we can, or because this is a word problem, we can try to make more sense of it. Before, this was our wage in terms of our hours, right? So maybe we use two variables. We'll replace this with a y and an x, and we'll find the inverse of it, which really isn't that hard to do in this case. If this is our y equals 15, that's our x plus 100, right? If we flip the two, this becomes our x is equal to 15 times y plus 100. Okay. Scroll down just a little. We move 100 to the other side, we get x minus 100 equals 15y, which means y is equal to x minus 100 over 15. Okay? But because we're written in function notation here, okay, another way we could describe this, instead of writing y, or remember we said w to the power of -1, another way we could write this is now hours, okay, in terms of wage is equal to x minus 100 divided by 15. So what does that mean, hours in terms of wage? Okay. Before we were finding our wage in terms of hours. So if I worked 1 hour, I got $15 plus 100, I made $115. Okay. But in this case now, and sorry, this should be a w in here, not an x. Okay. When I've inverted the function, say I wanted to find out how many hours I'd have to work if I want a wage of, oh, I don't know, $200. Okay, I plug 200 in for my wage. Oopsie. Thank you. I plug 200 in for my wage, and I can solve it. It becomes 200 subtract 100, which is 100 divided by 15, which gives us maybe like 80 or 8 hours or something like that. So roughly, approximately, whatever that is. It tells us our hours in terms of wage. So when we invert in function notation, it's like taking the variable on the inside and solving for the outside. And that's a lot easier to see when we write it in the old fashion. In the old fashion, before we had it equal to wage, if we were to invert everything, this would become wage minus 100 equals 15h. So hours is equal to wage minus 100 over 15. It's just when we're in our function notation, because we always talk about the function in reference to the variable inside, we write it a little differently. Okay? Now, domain and range. Because this is a linear function and it's positive, we have a y-intercept of 100 and it's going up like that. Do you know what the domain of this would be?
It's going up.
Yeah, it's going up and it's linear. Remember, it's a linear function.
The domain.
Here, I can show you on a graph here. Our domain. So let's say we have, we'll add another number here. I'll turn these guys off. It was 15x plus 100. Okay, so if we zoom out, does this ever stop left and right, or does it continue to go and go and go?
It's continued, so it's all real numbers?
Yeah. Now, because this is a word problem, the only thing is that technically there is a stopping point. Because 0 being our hours worked, I would never work negative hours, okay?
Yeah.
So it definitely is continuous.
All real numbers except for I mean, except below 0.
Yeah, it wouldn't be below 0, so we would call that greater than. So I'm just going to move this stuff down because this is like a profit function. So the domain of the original, okay, and this is the original one we're talking about. So W of H, the domain was XER such that X is greater than and equal to 0, okay? And what about our range, okay? Our range in that function YER, except that Y is greater than and equal to, and it's not 0 in this case. It's whatever our y-intercept would be.
100.
Yeah, because if we work 0 hours, we're still going to get $100. Now, of our new function, which is, I'll write it a little smaller, W of H, what happens is the range restrictions become the domain, and the domain restrictions become the range. Okay? So, our domain here is XER such that X is greater than and equal to 100. It's a little hard to see. And our range is YER such that Y is greater than and equal to 0. Okay? So our domain and range actually flip values, which is the same idea as our points flipping values.